Hi, Hornets, and welcome. Today we're going to be taking a look at part two from the general review, which I gave you on Friday. And in this video, we are going to be going over finding when a velocity is at rest given a position function, both by hand and with the calculator. And we'll also be taking a look at how we find the equation of a tangent line with the calculator, either by just finding x, y in our derivative, or by finding the entire tangent line in slope-intercept form. So here we go. I have taken the liberty of writing number 6 on the board here. So as you look at that, you should be able to see it. And what I want to do is I want to first find the derivative, which is finding the basic derivation. We're going to get 12t squared plus 2t minus 24. And from this, I can then factor out the 2, leaving me with 6t squared plus t minus 12. And this is where we then factor out 3t and 2t. And then we break the 12 down into a 3 and a 4. We know that our larger number has to be positive and the smaller is negative. This gives us the 2 zeros, 4 thirds, and negative 3 halves. Because we're talking about time and position, we do not go backward in time, and therefore we will only select the positive value, and the answer that I'm looking for is 4 thirds. If we're trying to use the calculator, we're going to turn on our calculator, and I'm going to zoom in on it so you can see it clearly. And you'll notice I've already taken the opportunity to put this equation into the calculator, and I have used x instead of t. I'm then going to go ahead and hit Math 8. This gives me the derivative. It's from n derive. And we're going to put x as the variable of differentiation. Alpha trace gives us y1. And we're going over all x's so that we can simply graph the derivative. To graph the derivative, make sure you turn off the original, followed by a zoom 6, where we can find the first x-intercept. That x-intercept is right here on the positive side, and we're going to have to now find it using second trace, find the 0, enter. We then want to make sure that we are below and to the left, and then above and to the right. Each time we hit enter, followed by enter, and you'll notice that our answer is sitting right there at 1.333 repeating. Question number 2 gave us the position function. Let's just go ahead and write the position function down and make sure that everybody can see it. So let me zoom back out again so we can do this by hand. And we're looking at 4t squared minus 10t, and then we have minus 6. If I take my derivative, I'm looking at 8t minus 10. I set my derivative equal to 0, and I solve. This gives me 10/8 equaling t, and therefore my t has to be 5/4. Now, working with the calculator, we're going to go back to the original. This time, I'm going to put in my function, 4x squared. I have minus 10x minus 6. I already have everything set up, so I'm just going to turn off the original. Remember, to turn off the original, we press enter when when we're blinking on the black box. I'm going to zoom in on this. And then I'm going to hit graph. Once again, I'm looking for the positive value. There it is right there. Second trace. Second trace will allow me to find the 0. And I want to be below and to the left. And then above and to the right, hitting enter at each position, followed by a final enter to get my answer of 1.25, or 5/4. For question number 8, we are now working with the position function, and I will need to zoom out again. And I have 2t cubed plus 3t squared minus 36t and then I have plus 12. Working with the derivative, finding my velocity is 6t squared plus 6t minus 36. And setting this up, I end up with 6t squared plus t minus 6. Factoring it down, I have t and t. I have a 3 and I have a 2. The larger number is positive, the smaller number negative. That's because of the positive t. This is all from Algebra 1 and a review. And I end up setting it equal to 0 and finding the two solutions. Because we only want positive values of time, I get rid of my negative. Going to the calculator, I'm going to once again go to y equals and put in the equation for position. 2x math 3, that gives me the cube, plus 3x squared minus 36x plus 12. I'm going to make sure that I turn off the original. So I put the box on. Let me zoom in so you can see what I've done. I'm going to move the blinking black box over the equal sign and hit enter. You'll notice the black box is no longer around it, and that tells me that the graph will not be on. Hitting graph, I'm simply looking for my first positive x. And there it is right there. I then hit second trace, followed by 0. I move over so that I am to the left and under, and hit enter. Above, to the right, hit enter, followed by enter. My answer is 1.9999999. This is because the graphing calculator is using a limit process. Hopefully we would see a 2, but we don't in this case. So our answer, although 1.99999 repeating, is equivalent to the 2 that we found before. Alrighty. The next piece that we're going to be asked to do is we're going to be asked to find when our tangent, or what our tangent line is. So for the first equation, we're looking at our function. Let me zoom out a little bit so we can see what we're working with. We have f of x, and f of x equals 3x squared minus 4x plus 1. They tell me at x equals 1. Now, I want to find out what I get, so I plug in my 1, and I locate what f of 1 is. You'll notice I have 3 plus 1 makes 4, minus 4 is going to give me, interesting, let's just make sure that I have this written down correctly, at x equals 1, so I'm plugging in my 1, and I get 3 plus 1 makes 4, minus 4 gives me a 0. Alrighty. Now once I have my 0, I'm going to find f prime. F prime of x is going to give me 6x minus 4, and when I find my f prime, I get 6 minus 4 is a positive 2. I now know that my equation of my derivative is y equals 2x minus 1, or y equals 2x minus 2. Alrighty, let's see how we can do this on the calculator. Working with my calculator, I'm going to go ahead and I'm going to put in, I'm going to get rid of that, and put in the original equation. So we have 3x squared, I have minus 4x, and I have plus 1. I'm going to graph this, and I'm going to locate the value. So I'm going to have second program. We want to draw the tangent line. Let me zoom in on that a little bit. So we started at our graph. We then hit second program, and I'm doing draw the tangent line 5 at 1, enter. And it's now going to draw the tangent line, and it's going to give me the equation of the line that I have already found. Y equals 2x minus 2. In the second equation that we have that we're working with, let's just zoom out again. We are working with f of x, and they give me x cubed minus 3x plus 1, and we're looking at x equals 2. If x equals 2, I have 8 plus 1 makes 9. 9 minus 6 makes 3. So I now know that f of 2 is 3. Finding my derivative, f prime of x, I get 3x squared minus 3, and plugging in 2, let's put our 2 there, we're going to have 12. 12 minus 3 gives me a 9, and I can now find the equation. Y minus 3 equals 9x minus 2, and there's the equation of the line in point-slope form. Now please take note, in the previous answer, we didn't have to put the 0 in, and so I did not. Let's go ahead and go to our equation, y equals, we're going to put in x math 3 minus 3x plus 1. I'm going to zoom in on it so you can all see what's happening. We're going to hit graph. Second program gives me the draw, the tangent line 5, and we want it at 2. We hit enter, and we get the equation of our tangent line, 9x minus 15. And that is the equation of the tangent line in slope-intercept form. The last equation that I asked people to work with, let me once again zoom out, gave me f of x equals 4x squared plus 5x minus 6 at x equaling negative 1. When I plug in my negative 1, you'll notice I'm going to have a 4, and I have minus 11, which is going to give me a negative 7. So f of negative 1 is negative 7. I'm then going to find my derivative, f prime of x, which is 8x plus 5, and I'm going to plug in the negative 1. I end up getting negative 8 plus 5 is negative 3, and I can now write the equation of my line. Y minus negative 7 equals negative 3 x minus negative 1, and we can simplify that to y plus 7 equals negative 3 x plus 1 for those of you who want to. This is then going to allow me to use the calculator, so here we go. Start by putting the equation in. Let me zoom in on this so you can all see it. We have 4x squared. We have plus 5x minus 6. I graph it just like I did before, and I do second program, find 5 the tangent line, and we are working with at negative 1, enter. There's the tangent line, negative 3x minus 10. And negative 3x minus 10 is the slope-intercept form as opposed to point-slope form. Alrighty, this is part 2 of our video. I hope that helped. Thank you very much for watching, and please remember to be kind to each other and to yourselves. Thank you very much, and be well.